Hello. Welcome to Qrator Labs Education Center. This video will demonstrate a route leak performed by an AS connected to two ISPs. As a result of the leak, not only will the traffic route change, but there will also be temporary unavailability of the services accessed by clients. VPC 5 Web Resource Server on the left. VPC 6 User Server on the right. In this scenario, we use additional providers AS1 and AS2 to increase the route length between the user and the web resource. First, we will check that there is connectivity between the resource, VPC 5, and the user, VPC 6, by tracing the route from the resource host to the user host and back. The traces go through routers R8 and R9, whose IPs end with .8 and .9, respectively. Next, we will use the show IP BGP command to check the routing tables on R1, top left corner, and R2, top right corner, and see that routes to the prefixes 100.100.100.0/24 and 200.200.200.0/24 go through AS1 and AS2. We'll generate traffic from the user to the web resource at IP 100.100.100.5 by running the ping utility in continuous mode. Now, we'll enable the autonomous system that will redirect routes through itself, i.e. perform the route leak. We see that the router has loaded, and BGP sessions with neighbors AS10 and AS20 have been successfully established. Next, let's check the router configuration, AS number equals 777. We notice that there are no filters on the interfaces with the neighbors. Returning to our setup, we'll check how the routing tables in the providers connected to the leaker have changed. Show IP BGP. We see that both routers now have a second alternative route, which goes through the leaker's autonomous system. It's also clear that this route was chosen as the best path because it has the shortest AS path. Next, we'll look at the trace for the traffic from the resource computer to the user. Trace 200.200.200.6. We see that the traffic is now going through the leaker's router, whose IP ends in .7. Previously, the traffic passed through AS1 and AS2, whose IP addresses ended in .1 and .2. If we check the traffic trace from the user to the resource, the result is the same. Now, we will generate traffic from the user to the web resource using the ping utility. We will simulate a failure of the leaker's router due to increased traffic load. In reality, traffic volumes in case of a route leak can reach several hundred gigabits per second. We can see that after the leaker's router failure, the resource becomes unavailable, DOS. However, in our case, after a short time, the session with the leaker was automatically terminated, hold time expired, and if we check the routing table with show IP BGP, we see that traffic has now returned to the alternative, old, route through providers AS1 and AS2. This is also confirmed by the restoration of ICMP replies to the ping requests. If we check the trace to the user, we can also see that traffic is now going through providers AS1 and AS2. Thank you for watching us. Continuous network availability. Continuous customers loyalty. Continuous business growth. Qrator Labs. your reliable ally on the digital frontier.